Hey everybody, Mr. Monahan here for 9.4b. The objective is to solve quadratic equations by factoring. Same objective as the last video. This is a continuation of 9.4. Before we get into our solving quadratics, we'll look at our Vertex word problem again. Remember, these types of problems, you're looking to find the vertex. Here's what it says. A volleyball is tossed into the air with an upward velocity of 24 feet per second. Its height h after t seconds is given by the function that's right here. So they've already given us the function. I don't need to know how to write the equation this time. But this number, this 24, it's b, but it's also how fast I threw the ball. This c term right here is maybe how tall the person was. Or this is how high the ball was before it was thrown, at the time it was thrown. The negative 16, remember, that's always a with these, and it has to do with gravity back down to the earth. All right, so when you see these questions, these two questions, when will it reach its highest point and how high is it at that point? This is a find the vertex problem. So this is kind of step 1 and 2 of that long graphing process. The ball will reach its highest point at the axis of symmetry. So that's negative b over 2a. Remember that formula we want to have you have memorized for quizzes and tests and those types of things. B this time is 24. So the opposite of b, negative b, is negative 24. Then on the bottom we have 2 times negative 16. Remember, it's okay if you get a decimal for these. It's not okay if you get a negative for these. You can't have negative time, or the ball won't be at its highest point before you throw it, okay? So when you do that, you end up getting a decimal, and remember, those are okay too. Decimals, there's nothing wrong with getting a decimal, especially in a word problem. But this one comes out to 0.75 seconds. We have typo. Sorry about that. But we have 3/4 here. So after 0.75 seconds, the volleyball is at its peak, and then now it's going to start coming back down at 0.76 seconds. Okay? How high is it at that point? We need to plug 0.75, this is just function notation here, into the equation. So we need to put a 0.75 everywhere there is a t. And then we just want to solve that. So you do 0.75 squared, you do that times negative 16, and you get negative 9. You do 24, you have 3/4 of 24 is a way to think about it. Or you can do 24 times 0.75, and you get positive 18, and then you get positive 5 from the constant. So it looks like we have a total here, if you combine all of this, of 14, and we're talking about feet, so it gets to be 14 feet above the ground. Okay, so those are just about finding the vertex of a parabola. It's just in word problem form instead of us having you go and graph it. Okay, so solving by factoring, this is what we talked about in 9.4a. So what we want to do, we want to make sure that one side is equal to 0, and both of these, we have that. We're good to go. So we want to try to factor these. And what that means is trying to get two numbers for this one that multiply to 45 that add to negative 14. So if there's no number in front of the x squared, we can put x's into our first spot. For this particular problem, I have a negative b term with a positive c term. The only way that's possible is with 2 minus signs. Okay, then I want to try to look at 45, and I want to try to look for something that combines to 14 when I add those together, even though they're going to be negative numbers. All right, so those are my options. I have 1 and 45, I have 3 and 15, or I have 5 and 9. If I look at 5 and 9, those will make 14, so I have a negative 5 and a negative 9. Those multiply to positive 45, but they add to negative 14. So I put 5 and 9. It doesn't matter since both of my parentheses have a minus sign. It doesn't matter which one I put where. But then I solve by factoring by splitting this up into 2 situations. If this product equals 0, I use the zero product property, And I know that if x minus 5 times x minus 9 is 0, either x minus 5 equals 0 or x minus 9 equals 0. Both of these solve with just one step. So x equals 5 is a solution. Over here I'm adding 9 to both sides, and I have that x is 9 is a solution. So if I plug 5 into the original equation, I get out 0. If I plug in 9 to the original equation, I get out 0. And those are the only two zeros that are possible. Okay? The second one has a negative c term, and it has a number out front, which makes things a little trickier. But I know right away, since I have a negative c term, I need one plus sign, I need one minus sign. Okay? I'm trying to make like a plus 1 in the middle. Out front, I now have to worry about how to get 3m squared, so I need to do 3 times 1 over there. 14, I can either do 1 times 14 or 2 times 7. Okay, what I have to remember now, sorry, this equals 0. Got to remember that part. I have to try to make 1 in the middle. All right, remember, whatever I choose has to get, one of the numbers has to get multiplied by 3. So if I look at the 3 and the 1 and the 2 and the 7, if I can do 3 times 2, that gives me 6, and then 1 times 7 gives me 7, those two will combine to make 1. If I make this a negative 6 plus a 7, that'll give me positive 1 when I'm done. So I want the 3 times the 2, and I want that to be the negative part. So what I want to do then is I want the 2 to be by the minus sign. I need the 3m to be away from the 2 so that those give me my negative 6. And then I need a positive 7 here, and I need my 1m right here. So again, what happens is these two will make 7m positive. These two will make negative 6m, and that gives me positive 1m like I wanted, like I have in the middle. Okay, then I'm at the solving step because I haven't factored. I have the zero product property that applies now. I have two solutions that are possible. One of them solves pretty quickly over here. Just add 2 to both sides. So m equals 2 is a solution here. Over here, I need to subtract both sides by 7 first. And I get 3m equals negative 7. Now I'm going to divide by 3. So my other answer is negative 7/3. I would just leave those situations as fractions instead of going and getting a decimal. We don't need the decimal there. But what that means, if I plugged in negative 7/3 into the original equation, I would get out 0. If I plug 2 into the original equation, I would get out 0. Those would be the x-intercepts if I graphed that original equation. All right, let's move on. Remember that before you do any of these, you have to make sure that one side is set equal to 0. So in this first one, I don't have that. So I need to add 42 to both sides. So on the left, I'll now have x squared, 13x, and positive 42. On the right, I'll have 0. And now that's something that I am able to factor. So I'm going to do that now. Okay, again, nothing in front of the x squared means I can put x and x. Everything is positive this time, so I'm going to put plus signs everywhere. For 42, I have 1 and 42. I have 2 and 21. I have 3 and 14. I have 4. 4 doesn't work. I have 6 and 7. And that's the one that I want. Okay, 6 and 7 will add up to 13, and they multiply to 42. So it doesn't matter where I put the 6 and where I put the 7, since everything is a plus sign this time. And now I have zero product property all set up. There's two possibilities here. X plus 6 could equal 0, or x plus 7 could equal 0. And that gives me two solutions. If I subtract 6 from both sides, one answer is x equals negative 6. If I subtract 7 from both sides, x is negative 7 is my other answer. The one on the right, I can't have this plus or this negative 5 on the right-hand side. I need one side to be equal to 0, so I add 5 to both sides. And then from here, I try to factor. This one, I can't I have to worry about how that there's a 2x squared out front, so that's going to impact things. But it is another plus problem. It is another problem that I'm able to put those in right away. Both my first term and my last term are prime for this problem. Okay, 2 is just 1 times 2, 5 is just 1 times 5. So I need to try to make an 11 in the middle. The way to do that is 2 times 5, because that'll give me 10. Then I have 1 times 1, that'll give me 1, so that'll be my total of 11. So I want, wherever my 2x is, I want 5 to be in the other parentheses to make 10, and then I have a 1 and an x for my last spot. This is going to be equal to 0, so now I can set up my zero product property and solve. This one solves faster, just subtract 5 from both sides. This one has 2 steps. So we're looking at 2x equals negative 1, divide both sides by 2. We have x equals negative 1/2. All right, so then what we'll move on to then is what if you can pull out a GCF first. And that will actually kind of be our only new thing from this video. Everything else to this point was review. So this one, notice how each of these terms has an h in it. So what we can do first is take a GCF out. So I see that right away. When I look at the numbers, 3, 17, and 10, they don't have a common factor besides 1, so I can't bring out any numbers this time, but I can take an h and put it out front. And then what I'm left with, I should probably show a little bit of work. I'm going to take an h out front, and then I'm going to divide everything here by h. And then what I'm left with inside is 3h squared plus 17h plus 10. All the h's went down by 1. Okay, so what happens here, I'm going to keep the h out front because we're going to talk about what that does in a second. I can now try to factor this piece into 2 parentheses here. So I'm going to have all plus signs. The only way to get 3 is 3 times 1. So I'm going to put 3h and h to make my 3h squared. And I want to try to get 17 in the middle with either 1 and 10 or 2 and 5. Okay, this one, if I do the 3 times the 5, that gets me 15. So if I can put the 5 here, 15 plus 2 more will give me 17 in the middle. All right, so then I have to remember this little step next, that what I have here, I have zero product property, but there's 3 things, 3 factors in my product. So there's 3 things that are possible. H equals 0, or 3h plus 2 equals 0, or h plus 5 equals 0. Those are all 3 possibilities. So this one's already solved, nothing to do there. Okay, if I plug 0 into that original equation, I get 0 out. This one, subtract 2 and divide by 3. So h is negative 2/3 as an answer. On this one, subtract 5, and that's an answer. So there's 3 possibilities for h. H could be 0, negative 2/3, or negative 5. So if you pull a GCF out first, just pay attention to, did you pull a letter out or a variable out as well? Because if you pull out a variable, usually h equals 0 is going to be one of those answers. And that should be it for today. Moving on into the next stuff for 9-6A. So that's it. Let me know if you have any questions on anything that was said here, and I'd love to help out. But go ahead and try the assignment and see how that goes.